Yeah, thank you for having us here this afternoon. So actually, our apology first, and Christina and I actually haven't really accomplished the entire module yet, but we plan to accomplish it in the next couple of days. But we would love to share what we have finished it, and would like to get some feedbacks on those sections, and because those sections will be extremely valuable for those accomplished section, and actually as well as for those sections to be accomplished. I will elaborate on why. So can you guys see my screen?
Could you update your browser, Tao? I just want to check if my latest publish update worked. Okay, great.
Okay.
Thanks.
Cool. So yeah, so I would like to start with just introducing the structure of our module from the high level. Then I will jump into each accomplished section after that. So our module is centered, the title of our module is Intelligent Earth, Computational and the title of our module is Intelligent Earth, Computation and Data Science Methods for Research. So with this module, we intend to teach methods, models, rather than focus on a specific sub-area of geoscience or earth science. So given that, we are kind of grouping our section based on by the technique and by the methods. And each section will be delivered with a peer review research, maybe one paper or more than one papers. So from the high level, our module starts with an introduction section, and then with the other four, I call it a thematic section. Section 2, which is the basics in environmental data sciences, and section 3 will be application of data analytics in environmental science, and section 4 will be explore extreme flooding, and section 5 is civil climate infrastructure. And Civil 6 is a special one, which is kind of a final capstone project. It is kind of a free range farm so that students can apply what they have learned and plus whatever new data they want to explore on. So I will start with the section 1. So the structure of section 1 is we start with the module overview. Then there is something special. Our module is we share, we created a survey for learners and as well as for instructors who are interested in adapting our module for their own teaching. And the last subsection is actually a dedicated section to explain how to adapt this module for your own teaching. Okay, so that is just the first section of the introduction section. I started by introducing why using the emergent data analytics technique is interesting and is needed, is necessary in the area of the big data. So I share some papers and provide some description, and also at a high level talk about what learners are going to learn at high level from this module. And also briefly go over the content of each sections. And then it's just some simple facts about this module. we define the target audience as, so with this module, we intend to serve a broad mix of learners who has maybe has no coding background or has a lot of experience in coding. So we strive to serve a mix of audience. And tools needed, I highlight. So yeah, basically the first tool is a computer with access to the internet, and the computer it's not necessary to have a very a very high performance personal computer, because we're gonna use most of the cloud computing platform, which is the second tool, which is a quasi HydroShare platform. And I want to highlight another thing about this module. As I mentioned, we have an intro section following by 4 thematic sections. So the ideal scenario, actually, not ideal, the recommended scenario, how people should use this module is they should assign students to different mix of sections based on the student's interest and based on students' background knowledge, how to do that. So that's why, okay. So then we talk about the overall, I will elaborate on that, how to do that, how to determine which students should study which sections. Then listed all the objectives for each specific sections. Okay, so next one is the form. So we created a form. So each student who registers for this module can click the link and provides their first their basic information, and then tells and each student can use this form to tell the instructor about their programming experience and their interest and the background knowledge in a specific domain science. By saying domain science, I mean I refer to as any sub-area of geoscience or environmental science. And based on students can also show their interest in this using this HydroLearn module, and the students can also share their project interest. This question is for the section 6, which is the final capstone project. So with those given information, hopefully the learners can know what's the background, what's the baseline of those students, and also will know each student what might be the suitable sections for each student, so that they can assign different mix of sections to students. Or if you are applying, if you are using this module in your class, hopefully your class will have relatively similar background in terms of domain knowledge and coding experience, so that you can decide for your entire class what section, what mix of sections your class should take.
Do you want to? Oh, yeah.
Oh, you want? Yeah.
Oh, I just wanted, when you get to showing the rubric, how the rubric, our goal, which is not completely connected yet, but that the rubric that you see later, it's connected to this baseline somehow, or the template. Yeah, I mean survey.
Yeah. Then the last subsection of the intro section is how to adapt this module. It's basically what I just described. So with this, we are stepping into the second section, which is the first thematic section. So yeah, in this module, we teach a wide variety of techniques, including geospatial tools, machine learning tool, and also physics-based model. For example, LearnLab. So in section 2, the section 2 title is basically environmental data sciences. So don't get misled by the title. So we are not just talking about the basics of like a Python R coding without a context. We're trying to put students in the context. So they will be using environments, the authentic environmental data sets to try those basic operations in R and Python coding and cloud computing, and so that they can get some sort of a first-hand experience. So at the start of the section 2, I started with introducing the learning objective. Yeah, let us take one step back. Let's talk about the structure of section 2 first. So in section 2, the subsections in the section 2 is start with the introduction, basically talk about the overall sectional structure of this section 2, and then they talk about some basics about Python and the Jupyter Notebook, and then I demoed an application or demoed a case study of using Python and Jupyter Notebook to build some machine learning model, and I will elaborate on that. And then next subsection is talk about some basics about R and R Studio, and then next is similar to this one, is talking about how to use R Studio to do to build a data-driven model. And then the last subsection is, as I said, we strive to serve a wide mix of learners with a different level of background knowledge in coding. So we also provide some additional learning materials for those learners who need more practice in coding. So with this, let's jump into this section, Python and Jupyter Notebook basics. So in this subsections, we will use HydroShare as the platform to do all the computing. So students are supposed to create their own HydroShare accounts and join our course group hosted on the HydroShare website. And then the learning activities, they're supposed to use one HydroShare learning resource, which is hosted here. So when they click the link, they will be redirected here. Melissa, how many time do I have? How many more minutes do I have? Just make sure I'm not going too slow.
Aaron, you have 8 minutes left.
Okay, so and then they just click open with the Jupyter, the quasi Jupyter Hub. So I already opened that beforehand to save some time. So as you can see, the folder structure. So they have 2 folders. One folder is for Python specifically, and the other folder is for R and R Studio specifically. So when they open this folder, the first folder, they have all kinds of learning activity related learning resource about Python and the Jupyter Notebook. So when they open the Jupyter Notebook, in the past weeks, I have worked. I've been trying hard to revise those Jupyter Notebook to add comments to make it more interactive, so that students can walk through those Jupyter Notebook relatively easily, and also they can really gain some knowledge. And so they are supposed to run each cell, and they will know what's going on and how to use Python Jupyter Notebook on our clouding platform. Okay, go back to the structure. So basically that's the learning activity. And after that, because that's just the section 2, I use this section trying to give some basic, trying to introduce some basic concepts to students. So I just use some very simple questions, check and understanding questions, to make sure they are not just click run and without going back to check all the results in that Jupyter notebook. I want to make sure they have run all the codes and they really digest what they got out of those codes. So that's just those questions are used to check they really understand how to use Python and Jupyter Notebook. And then, so it's the first bite of machine learning in Python. So basically, I use a real environment, the actual wildfire data sets to introduce how to build up a machine learning model to predict the severity of wildfire using Python and Jupyter Notebook. So I start with a YouTube video introducing what wildfire is and what's the benefit and what's the environmental cost associated to wildfire. So that students can get a sense. And then we move into the learning activity. Again, so when we use the same HydroShare resource, and they're supposed to run the second Jupyter Notebook, and they're supposed to review codes in that notebook and modify those codes and interpret results from that notebook. And and I also gave the detailed rubric about this learning activity. And as to the deliverable, I provided a template about what they are supposed to deliver. Okay, then next two subsections are very similar to the Python one. They are just talk about R and RStudio, but I do want to maybe mention the first bite of machine learning in R. I still use wildfire, but I kind of in the Python, I highly simplify that wildfire learning activity so that students don't get discouraged up front. And then, but in this case, I show more details about how to build a machine learning model. For example, the feature engineering. That's all the things we need to worry about. But in the earlier case, I didn't show those show students those details. But here, I asked them to walk through all of those details. Okay, so, and then section 3 is actually this overall structure is pretty similar. Basically, in this section, I introduce a geospatial tool, which is SWGT, representing a sliding window geospatial tool. So I started by introducing the tool, about the technical details about the tool, and then talk about some of the background of the domain science, and then introduce and using a learning activity. I talk about the resource and rubric and instruction steps. And students will also use the HydroShare platform for computing, but this time they will use another HydroShare resource. Okay, I will just stop here so that Christina can talk about, add something.
Okay, what I was just distractedly doing is I'm supposed to be leading another meeting at 12 o'clock, so I just was delegating that because I didn't manage the timing right. So do you want me to, Tao, if you go to the explore extreme flooding. So for section 4, if you look at it here, what I did, or what worked for us is I duplicated Tao's section 3 so that the students, there's so many complicated things happening actually once you are going to HydroShare and then you're going to notebooks and all of the structure of what's expected. I'm using the exact same structure of section 3, but then I just changed, well, the content. So if you, and what I wanted to mention is the types of, so options for the introduction is you'd be running the notebook, but the learning activity, let's see, if you, the check your understanding, I've got 2 levels of check your understanding. So one, you can run the notebook and check your understanding just by answering these questions. So even if you don't do anything else, you can answer these questions just by running the default notebook. Whereas in the next section, after the introduction, is the check your understanding.
You mean this one?
Is, yeah, yes. No, not the introduction. So if you go down to the
This one.
overland flow routing, right? That check your understanding should be, you might have to refresh your browser.
Okay. No, it's not.
Not there.
Learning activity?
Oh, it's in the learning activities. Sorry.
Okay, no problem.
Okay, so the learning activities, so these are the same summary questions, but once you get through to the end, you're introduced with the questions that you can answer just by running it and not doing anything. But by the time you get to the end of this section of the module, you've gone through and run the notebook so that it's got, you're creating maps, you're creating spreadsheets, you're creating all of the details that would go into the authentic task is oriented around presenting the conceptual background of an equation that is in a flood model. Why do you, and explaining it in court to a judge. Why is this, should this area be developed or not? Is it predicted to be flooding in a storm? The model runs the storms, and then you have to explain the conceptual understanding of the equations and the concepts of the flooding that validate that your model is good at, you know, predicting floods to someone who's not an expert, and as well as provide all of these detailed what can be created from the notebook and all of the details of the spreadsheets and numbers that would need to go into all of the files for court to validate your model. So that's the scope of the authentic task. And then I guess to show one thing that I did different that I'd love to get opinions on is the notebook itself. Well, so if you go up Tau to the resources, or I could just show my,
Yeah,
how are we on time?
So we've passed our time for today. Is there something quick you'd like to share?
Nope. I guess I wasn't sure about the trade-off of having more figures and images in HydroLearn as well as in the notebook, and what would be the benefit of doing that. So Tau, if you just, that's fine. So
just let me know where I should go.
I'm trying to read your small print, and I'm going to say, here is in the chat box, I guess. The other thing I was hoping you could show, Tau, is what does our classroom group look like and all of the resources?
Oh.
If you have that tab open, that might be interesting for people to see.
On HydroShare?
Yeah, so we have a group for the course.
Collaborate.
Since we're going to be teaching it at multiple times with different people. So if you go in, I can find the link. So all of how we asked people to submit their work was through this course page. And so part of the authentic tasks that I thought would be nice to highlight, or people might be interested in, that these resources are all not resources just for the course, but they're resources that are from like current projects going on or current publications that have been, that people are building on, so that it feels more like a community, and you're building the authentic task of publishing data and working with the cyber infrastructure is real, because it is. So